Here's a concrete version of the system. I think you're imagining. Build a modular neural audio rack, where each module looks and feels like a synth. But internally, it is one of three things. One, fully learned effect. Learned resynth. That direction is grounded in existing work. DSP gives interpretable DSP building blocks inside neural systems. Rave gives real-time controllable neural audio synthesis. DiffMoog shows differentiable modular signal chains. And Newtone shows that neural audio models can be packaged with host-facing controls and metadata. What the rack would contain. I'd start with only. I'd start with only. I'd start with only. What the rack would contain. Use case.
Learn a processor from examples.
Make this behave like my weird favorite chain. Internally, this could be a compact real-time model trained on paired examples, then exported with a few macro controls. Newtone is relevant here because it already supports wrapping PyTorch audio models for DAW use and exposing control metadata in the plugin UI. I'd start with only. I'd start with only. I'd start with only. Latent representation, resynthesized audio out. Use case.
Turn this into that family of sounds.
This is where Rave and DDSP are especially relevant. Rave is designed for real-time neural audio synthesis and timbre transfer style use, while DDSP is built around interpretable synthesis components like oscillators, filters, and wave shapers.
Reshapers.
Use case. Use case. Use case. Use case. Learned oscillator bank. Learned exciter into physical-ish resonator. Learn a wavetable-ish instead after training. Run a control discovery step that finds directions in the model that correspond to perceptually meaningful changes, then expose only those as knobs. That means the system should try to produce controls like body, 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 body. This part is partly a proposal, but it is motivated by the known problem that neural models often have powerful internal representations that are not naturally human playable. Rave explicitly discusses latent space control, and Newtone's UI metadata shows the deployment side of assigning understandable controls. I'd make training work like this. Learn an effect from examples. User, 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 user. User, user. User provides. The system does.